Hello everyone, in this video we will start wave optics. So we will start Huygens principle. So till now we know all about light, that whether light is of particle nature or whether light is of wave nature. We now know what scientists said about light, about Newton's corpuscular theory, and about Huygens, that how he found out light and how he told that light is of wave nature. Now we will study about principle which were given by Huygens. So our first principle is of wavefront. So Huygens' first principle was of wavefront. So what is a wavefront? Let's see. Wavefront means wavefront. Wavefront is the locus. Wavefront is the locus of all points of the wave. So what do you mean by locus? Locus means peak point of the wave. So example, if this is a point source, means in this light are coming in the form of waves from this source. So light are going in this direction, light are going in this direction, light are going in this direction. Light is coming from this point source. So according to Huygens, wavefront is the locus. Locus means peak point. So what is the peak point of this wave? Peak point means top point. Since the waves are starting from here, this is the peak point. This is the peak point of the wave. This is the peak point of this wave, and so this will be the peak point of this wave. This will be the peak point of this wave. This will be the peak point of this wave. This will be the peak point of this wave. So according to Huygens, wavefront is the locus of all points. Means if we will join this locus, then we will get a circle. And this circle is called as wavefront. So Huygens told that we see light in the form of wave, but Huygens thought this light to be a circle, a big circle. Means this was the thinking of Huygens, that he told that we can think light waves are all the light waves are having common peak points, and these peak points, if we will join them, then we will get a wavefront. This was the thinking of Huygens. Example, if in this example it will be clear about wavefront. If this is a wave, means if it is a river side, then you can see waves like this. This is a wave. So this is not a single wave. In river you see many waves. In backward also there will be a wave going in this direction. This is also a wave. This is also a wave. So what you see in these three waves common, and this will go till on like this will go, the waves will start going like this. This is a river. So what you see, that they have a common point. This is the peak point of this wave, first wave. This is the peak point. This is the peak point. Peak point means the toppest point, the top point. This is the peak point. In the second wave we are having this as peak point, this as peak point, this as peak point, this because this is the topmost point. And in third wave we are having this peak point, this as peak point, this as peak point, this as peak point. So when we will make a perpendicular line through this peak point, what we will get? We will get lines, and these perpendicular lines are wavefront. So we are seeing this in this position, but if we will see in the topmost position, means if our eyes will be here, So we will see these circles are forming in the waves, and these circles are wavefront. This is the side view and this is the top view of wavefront. So according to Huygens, if it is a point source, this is a point source, means in this light is light is coming out from it. Light waves are, this is a point source, and in this light waves are coming out from it. And if we will take the peak point of all the waves, means Huygens told that light is a wave, so many waves are coming out from this. And according to Huygens, if this is the peak, if we will join all the peak points, peak point means locus, if we will join all the peak points, then a circle will be formed, and this circle is called as wavefront according to Huygens. So according to Huygens principle, there are three types of wavefront. So first we will study about spherical wavefront, that what is a spherical wavefront. So we can see it is written, spherical wavefront is formed when the source of light is a point source. Means in this we have taken a source of light. Source of light means in this source many waves should emit. This source should emit many waves, many light waves. So this will be called as source of light. So according to this, if he said that Huygens told that this is the source of light and this many light waves are emitting by this source of light. So if we will join the peak point of this point, the peak points, this is the locus, locus means the peak point, then we will get a spherical wavefront. This is the wavefront and this is spherical in structure, so it is named as spherical wavefront. Now our second type of wavefront is cylindrical wavefront. So cylindrical wavefront are formed when our source of light is a line source. Means in this is the source of light, this is the source of light we have taken, and this is what source is this spherical, this is not, this is a line source, means this is a straight line, and in this many light is getting emitted by this source of light. So some light waves will go like this, some light wave will go like this, some will go like this. Many light waves are getting emitted, means many light waves are getting out from this point source. And if so, these are the light waves which are going from this, traveling from this point line source of light. So if we will join the locus, so what will be the locus of this waves? Locus means the peak point. So this wave is having this as peak point, this wave is having this as peak point, this wave is having this as peak point. So all the waves are having their peak points, and if we will join them, then we will get somewhat like a cylindrical shape. That's why this is called a cylindrical wavefront. So in line source we get a cylindrical wavefront. So this is the locus, this is the light wave coming out from source of light, this is our source of light, and cylindrical wavefronts are formed. Now let's study about plane wavefront. This is our third type of wavefront. So in this we can see that when the point source or line source of light is at infinity, then the wavefront will be in plane. Means in this our point source is, means this was our point source, this is our line source. In point source spherical wavefront was formed, and in line source cylindrical wavefront was formed. So in this it is written, when these both sources, any source can be present, if line source is present at infinity or if the point source is present at infinity, then the wavefront after some time will be of this, the wavefront after some time will be planes, and this is in the form of planes, so this is called as plane wavefront. So in this we can see that sun acts as a point source. So sun is at infinity, but light, instead of forming spherical wavefront, comes in a straight line. When we see sunlight from earth, we do not see spheres of light, we do not see spherical wavefront, we see what? We see straight light coming through in our eyes. That's why we can tell that when the point source is at infinity, our sun is at infinity, then the wavefront is plane. That's why we see light as straight line, because the point source sun is at infinity, and in this plane wavefront or straight line will be formed. That's why plane wavefront is formed from the point source. It can be line source also. Now let's revise what we have learned. First, we have learned about spherical wavefront, that in this spherical wavefront is formed when our source of light is a point source. This is our point source and many light waves are emitting out from this. This is the locus of all the points. If we will join them, then spherical wavefront will be formed. Then we have seen about cylindrical wavefront. If our point source is a line, then many waves are getting emitted out from this. And if we will join their locus, means their peak point, this is the peak point of this wave, this is the peak point of this wave, this is the peak point of this wave, and this is the peak point of this wave, then we will get a cylindrical type structure. That's why this is cylindrical. And we have learnt about plane wavefront, that if point source is at infinity or if line source is at infinity, then we will get plane surfaces. Plane surfaces will be formed in this, like this, like this, like this. This will be only formed if our source is at infinity, or if our source is a line source or spherical source is at infinity, then this will be formed. Now let's learn about wavelets. That what are wavelets? Wavelets are also called as secondary wavefronts. Means if we will take an example of point source, this is a point source, and in this many waves are produced, like this, like this, like this. Many rays, light waves are emitted by this point source. So many light waves are emitted. So according to wavelet, first we will match their locus. After matching their locus, we will get what? We will get a wavefront. We will not get a wavelet, we will get a wavefront. Then according by this, we will see that here are also waves. So in this also there will be locus, 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 and these locus are also forming waves like this, like this, like this, like this. So these waves are called as secondary wavelets or wavefronts. In this also many locus are formed, in this also many locuses are formed, and this also comprises of some locus. So we will match this also, and so these waves which are formed next to the wavefront is called as secondary wavefront. This can be called as secondary wavelet also. Now let's study wavelet in more detail. So wavelet is the wave formed by point source. So here we have taken a point source, many waves are getting emitted by this, and first we have joined their locus. Locus means peak point of this wave. So peak point of this wave is this, and we have joined them. So after joining them, we get a wavefront, and this is also a wave. This will also make its own wave. This point will also make its own wave. This point will also make its own wave. So here, after making its own wave, in this also light waves will also get emitted. So light waves are getting emitted, and in these waves also there will be peak point. So there are the peak points in these waves. These peak points are called as locus, and here we will join this locus. So what will be formed? Wavefront will be formed, but these waves are this wavefront is arising from this wavefront. That's why this is called as secondary wavefront. This is also called as secondary wavefront, because in this wavefront, this wavefront is arising from this wavefront. If this wavefront will be absent, this wavefront will be also absent. So this is called as secondary wavefront. That's why This secondary wavefront is also called as wavelet or secondary wavelet. So this is our wavelet, this is our wavefront, and this is our point source. Let's now learn about Huygens second principle, which tells that third principle. The first principle was of wavefront, second was of wavelet, and third principle tells that if this is our point source, and in this if many waves are getting arising, these are the waves, these are the waves, these are the waves, these are the waves, many waves are getting arising from this point source. So this principle tells that the wavefronts will be perpendicular, means the wavefronts will be perpendicular to light rays. This is most important because this is used in all the questions in examination. This tells that, this principle tells that if many waves are getting arising from this, many waves are getting arising. So in this, first we will make wavefront. So this is our wavefront locus, this is the peak point, this is the peak point of this wave, this is the peak point of this wave, and this is the peak point of this wave. So first we will join them. We have joined them. This is the wavefront, this is the wavefront of this wave. Then we will see that many secondary wavelets will be also formed, secondary wavefronts. This will have this own wave, this will have its own locus, and this will also be formed. So what we see, that we get a circle like this, we get a circle like this. So this principle says that according to Huygens, the wavefronts are perpendicular. The wave is always perpendicular to wavefront, means this is the wavefront, so our wave will be always perpendicular. It will be like this, perpendicular. It will be like this. This is perpendicular, this is perpendicular, this is perpendicular. So our waves will be always perpendicular to wavelets. This is applicable in examination. From here you can understand little bit about wavefronts and waves, that this is our wavefront and our waves are perpendicular to this wavefront. Now let's take an example so that wave nature, wavefront is more clear to you. Let's take an example. You are here and this is a river, and this is a big river, and you are here it is a stone, and you took this stone up and you threw this stone in water. So this is a river, as you know, and you threw this stone in water, means this stone was thrown by you in this water, in the center of this river or in anywhere. This stone was thrown by you in water. So when you threw this stone, what will happen? You will observe many circle will come around like this, and only till only 3 or 4 circles will come, and after this whole again the water will become still. So what you understand, in this stone is acting as a point source because our stone is spherical in shape, and you threw this stone in water. When you threw this stone, since it's acting as point source, many waves are getting emerging, many waves are getting emitted out of this. These waves are forming these peak points. These waves are having peak points. These peak points are called as locus. We have, and this, after joining this locus, a circle is formed. This locus, in this many waves are getting arising. These are also peak points. These are also having locus. This is also getting surrounded by this, a circle is getting formed. This will also a circle is getting formed, and this circle, you can see by this, this is the best example to explain wave front and wave nature of light waves. So by this it will be clear to you what is wavefront and what is wave nature, that if this is our point source, so and this is our light rays which are getting emitted out of this point source, so this locus means this peak point will be our wavefront in this, and the waves are also having the wave, and these are also the waves, so it should also have a, it should also form this, these waves are also acting as a point source, this is also also acting as a point source, this is also, so it should also emit wave with light waves, and these light waves should also have locus. If we will join them, we will get a wavelet or secondary wavefront. So now it will be clear to you what is a wavefront and what is wavelet. Now let's see behavior of lenses. Now let's see behavior of lens. So this is our convex lens, and in this many light rays are coming parallel to it. So we already know that if it will strike the convex lens, then the light ray would become converge, and we know that the wavefront is always perpendicular to light rays, as I had showed you that the wavefront is always perpendicular to light rays, and these are meeting at a point because this is converging. So what you see that this point is acting as a point source, and in this, from the example we see that many light waves are getting emitted. You can see here many light waves are getting emitted. So when this acts as a locus of point, and we see that a sphere will be formed, but in this we can see sphere will be formed because this acts as a point source and many light waves are getting emitted. That's why the refracted wave front will be a little bit curved. Then next come to this example. This is a concave mirror. Light is getting parallel and striking to this mirror, so we know that the incident wavefront will be parallel to the light ray. After striking it, it again converges, and this it meets as a point, and we know that this acts as a point source, means this is light ray, light waves, and this is the wavefront, because in point source spherical wavefront is formed, as we have seen the example. Now let's see behavior of a prism. This is a prism, a parallel light is struck into the prism, and this is a wavefront, because we already know that wavefront is always perpendicular to the light ray. Again after striking, we know that prism will tilt this light and whipgore will be formed. So after tilting, the light ray are coming in this direction, but after tilting it became this, so it became this. So wavefront is always perpendicular to light ray, so it will be perpendicular will be drawn, and the angle should be 90 degree. That's why we can see that here the angle is 90 degree, here the angle is also 90 degree, and our wavefront will be formed. So these were the examples of wavefront, wavelet, and behavior of lenses. So in the next lecture we will start reflection of light according to Huygens, how Huygens explained refraction of light waves according to his theory. Thank you for watching this video. Thank you.